we started streaming, I think. Hello, everyone.
Hello, everyone.
I can hear myself.
Can you hear me?
Yeah, I don't know. Wait, hang on. Can you speak?
I am speaking. Can you guys hear me?
Okay, I think they can hear you. I'll listen into the stream just in case.
Is anyone actually watching the stream at the moment?
No, because I haven't pasted the link.
Alright, fair enough.
But I will do that right now.
Also, the YouTube video link from last time is still being processed by YouTube.
The stream, just in case. Sorry, say that again?
Is anyone actually watching the stream? The YouTube video link is not still being processed by YouTube, I think.
Oh, no, yeah, the YouTube... Oh, right, I see what you mean. You can delete that, but yeah. I'll edit that. Do that right now. Okay, and let's go. Here's the link. Sharky, can you find the link to the... Why can I not get this?
To the overleaf?
Nah, to the YouTube stream. I'll see if I can find it. Why is it so hard to obtain? Oh, there it is. Oh, I got it.
Right, okay, just gonna go into... It's got the channel, right?
Yeah. But like, I don't know, hang on. Oh yeah, I pasted the and alright, that's the Jamboard.
Yep.
Stream looks okay, I guess. Do you have the overleaf?
Well, I mean, we were just using it yesterday, last time's
Right.
right?
Oh, yeah, I remember.
I have the problems up. Oh, and probably notification squad.
Alright, let me find the problems as well. Alright. Should we start now, I guess?
Yeah, sure.
Alright, 1407. Oh, well, it's 1407 here.
Let's scroll down. Problem 5. There are 20 positive integers for the zooming right. Racist. Oh, okay, so it reduces it down to one number, but it's one of those numbers. Huh. 2020. Just ended up with the single number 2020 instead. Interesting. Okay. You read the problem yet?
Nope.
Oh, what are you doing?
I'm still configuring the stream. Why is this always?
Okay, that's interesting. I'm just gonna do some small cases. So A, B goes to like 2 minus 2. Now this would imply B minus A equals 2.
Interesting problem. I just read it.
Yeah. I'm just doing some small cases. Maybe there's like some sort of transformation we can do. Or 2, clearly it doesn't seem to be always possible. I think. Like if A and B were both -1, how would you do it? Oh, they're positive integers. Never mind.
Right, yeah, well, good point. I didn't realize that either.
Yes, that might make it actually. Might visit specific properties. So like if
Yeah.
it's
So
1,
that means like a subtraction must have happened at some point.
right? Yeah, exactly. So therefore, the subtraction must have occurred. Surely that means you can just invert it, right? You
Yeah,
can just invert
I'm pretty sure.
subtraction.
I'm
So
pretty
just
sure that
is
just
fine.
works straight up. You just
Yeah.
take that subtraction step and you like subtract it the other way around.
Yeah, it just works, right?
Exactly. And then everything else will preserve like positive or negative, right?
Exactly. Well, that was easy.
Um, I'm just making sure this works. Like, is it true that if you just invert that single subtraction?
I think you invert every subtraction, right? If you have something like this, then that goes to like yeah. Wait, does that work?
No, but like you might have a bunch of other like operations. Oh, I don't know. I mean, like the other operations don't matter, right? Because
No, they don't, because they don't change the parity, do they?
unless like, what about if it's addition?
Wait. So basically, I think we want to just show that you can always invert the parity. So let's just do some small cases just to double check.
Yeah, yeah.
And maybe we can figure out for real. A, B, C goes to 3, I guess. Hmm.
Oh, okay. Wait, I think there's another way to do it. You don't even have to show that. So, um, you can do the same operations, but have the numbers in an order so that at all times, all of the numbers that have been written down are positive. Then that doesn't change the absolute value of the set of numbers, and that means that at the very end you have to end up with 2020, right?
Um, yes.
By like absolute value stuff. Yeah.
Yeah. I'm just thinking, will that change in your additions though?
Um,
Like if you have a plus like the absolute value of an expression versus a plus like the negative value of that expression, that'll just change, right?
because like if you have a plus something, you can always use like a minus that thing if you need to.
Okay, yeah, that's fair.
Yeah,
Yeah.
using any two numbers, you can make the positive version of any, like, if one of those numbers was negative or if both of those numbers were negative, you can always make the um, positive version of the result if you start with the positive version of both of the two numbers at the start.
Yeah.
So okay, so the now all we need to show is that, like, if we start with A, B, and we can get to C, then that means that if we start with absolute value of A and absolute value of B, then we can get to absolute value of C, right?
Yeah.
Yeah, and I think that's just a case bash.
Yeah.
And I think so. Okay, I guess we can do the case bash. Suppose A and B are positive, right? Then that's trivial. You just do the same operation. Suppose, like, I don't know. Like, there are only 4 cases. So 2 positives. This is trivial. Wait, how are you there?
Yeah, I'm
Okay,
thinking.
okay.
I'm just thinking about maybe we can do the subtraction inversion thing as well though. Like if you just do it to the last
Oh, the
subtract,
last subtraction that happens.
and then
Oh,
like
maybe.
like do a thing that you transform each operation after that as well. So like if you had like a as one of your results, it becomes now like minus a. and then like if it was a plus b, then that becomes like minus a minus b. If you have a times b, that just becomes minus ab. And if it's a divided by b, it comes to minus a over b. Yeah, same thing with the one. Yeah, this works, I think, actually. This subtraction inversion thing. Just by using your kind of idea of inverting the addition to a subtraction thing.
Yeah, I mean, I think my thing also works. I mean, I just did the cases, and
Yes, did I?
this is the same as above.
Yeah. So yeah, this definitely works then, therefore.
Wait, hang on. A minus b. That would be minus a plus b. Oh right. Wait, hang on. I got these the wrong way around. There's b here and a here. Yeah, and I'm pretty sure the two negative cases the same. I mean, yeah, we have like two different solutions.
Yeah. My solution is like, okay, if you convert the last subtraction, then you can show that you can change the addition operator such that it works negatively, and the other ones just trivially work negatively. And then you can just induct upwards from there. Okay, not bad. That took us, what, 10 minutes?
Well, yeah, I mean, we got the idea pretty quickly, so probably less than that kind of. But we have to write it up later.
Yeah. Question 2. Question 6. Final images and which these following statements true. Piece of complex angle such that ms1 sides have equal length and ms1 sides have equal measure than piece of regular polygon. Ooh. I'm just thinking, if you have n big enough, they can surely just go like this, right?
I haven't read the question yet. I'm still prepping the stream. Okay. Oh.
Can I think of quadrilateral just three equal angles, but one of them's different?
Quadrilaterals. I don't think.
A normal one that like
I feel like. Wait, quadrilaterals don't work, right?
So I'm trying to
do they? Oh, I see. Yeah, no, quadrilaterals don't work. So you have to have a square.
Wait, why?
Because if you take one angle and just kind of repeat it, right? And you take one length and you repeat it, and you have the last one, and it doesn't meet the first one.
you don't know for sure that the angles definitely like are associated with the side, right?
Yeah, it's not, but in minus one of them have to be equal. So like, it's like they have to be consecutive, right? So you can start somewhere.
Oh yeah,
Um,
fair.
yeah, and then you like it's like you're traveling, and then you turn a specified amount and you travel in that direction for
Yeah.
the same amount, and then you turn the same amount again and you travel, and then once you turn for the last time, then it just won't match up with.
Sure.
It won't pass through the first starting point.
Okay, but are you starting with the length in your thing, or are you starting with the angle? Because the angle could be anywhere. Like what
I'm starting with
angle
the length.
is here?
Sorry.
What if you separate angles like up there instead? And like these are all the same length, right? That's what you're trying to do.
No, because the angles. So the angles have to be consecutive, right?
Yeah. So what if this is the one spare angle?
Oh, I see.
Can't assume both start at the same point,
Oh, yeah, that's fair.
which is why. But like, yeah, if you try to do your thing, you get like a rhombus thing coming out or something.
Wait, do you what?
Wait, let me see if I can.
Surely this should be like over here, right? I'll use yellow or something.
No, this is like an angle that is different or something. I don't know. Okay, but it's difficult to construct a quadrilateral which for which this satisfies. And yeah, this is like kind of my construction, I think, for odds, which should work. I think.
Yeah, yeah, okay.
It might be like a cyclic thing.
Yeah. Wait, no, it can't be a cyclic thing, right? It would have to be
No, it wouldn't. But wait. Hmm. Okay, let me I have to go with like sort of angle bashing this. Just see what happens. Okay, what should I label these vertices? Like P1, P2, P, and go like PN. And what we have like we can order it so it's like angle P1, this one equals like alpha. Then angle PN equals to 180 minus 360 over no, not that. 36. Where is it? What's the formula? 180 and minus 2, right? Yeah. 180 m minus 360 minus n minus 1 alpha.
yeah. So I'm pretty sure it works for odd.
Yeah, that's what I'm thinking. And then for
Um,
even, should die for some reason. Okay, so this is a convex shape. So what? This has to be less than 180. So add 360. That's 540.
yeah, okay. Odd does work.
Yeah, just
So
by symmetry.
even for some reason doesn't work. I don't know.
No, wait, this is minus alpha. So alpha is greater than that. I think, if I've done that right. Does that look right? Alpha is greater than 180 and minus 540 over n minus 1. Wait, sign-
Um,
wait, yeah, that seems fine. Wait,
um,
it's like ugly. Let me just write this out.
are you
One day,
sure that doesn't? Are you sure the inequality goes that way? Hang on. I don't think it does. I think it goes the other way.
no, it goes this way because
Wait,
you
what?
flip, right?
You put this here. 540 minus 180.
This looks so much nicer.
All right. Yeah. No. 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 You're right.
Yeah, this looks so much nicer. Okay, I'm totally gonna just replace the alpha with 180 minus alpha because this just makes it look so much nicer. So alpha minus 180 then. This is gonna be minus 180. So it'll be 180. Okay, there we go. If the angles are 180 minus alpha, then alpha is less than 360 over minus 1.
Okay. Nice.
Just it looks cleaner than the other thing it was there before. Hmm. You can totally complex batch this, right? Like surely, like if you have all the sides be like length 1 except for one of them, then you have like each angle is the same except for one of them, meaning that if you have the complex number coordinate, complex coordinate like vector kind of things, it's like you could set like let me do this right. And P1, I think. Yeah, you could set this to be that. Oh, P1, P2 to be like Z. Oh wait, what would be it'd be e to the I alpha. Wait, let me think. So if you have like one alpha, what's this gonna be? It's one. It's gonna be e to the I alpha. Yeah, that looks right. alpha.
Are you actually
Okay.
complex bashing this?
Yes.
Okay.
Well, I mean, they actually work really well with polygons, like this kind of stuff.
Right.
There's lots of
Okay.
equal angle length, right? You can totally do this to I alpha, and then like you go on to like Pn minus 1 Pn equals to like e to the, what is it, n minus 1 alpha, like n minus 1 I alpha, yeah. And one of them like P, like what, m minus 1 m equals to like k times that, where k is some scaling factor. Where totally should have been pm plus 1. Okay. Yeah, this looks right. So this is what we have. So some so we have some I equals to 0 to n minus 1. Wait. Wait, what would be, yeah, n minus 1 e to the, oh, why did I choose I as an index? E to the I times j alpha equals to, what is it, k minus 1 e to the I m alpha. So wait, this is no, it'd be 1 minus k. What am I doing? 1 minus k. Always made a bad sign error. And therefore 1 minus k equals to, what's the sum of this geometric series going to be? What's the formula? It's like 1 times r to the m plus 1, so it's e to the I n alpha minus 1 over e to the I m alpha this is going to be e to the I alpha minus 1. Should be right. And now, this is a real number, which means it's equal to its conjugate. Always nice, complex number stuff.
No, I think I solved it as well. Using a different method.
Oh, yeah.
Yeah. So I can go to slide 4.
Okay, just wait, let me just...
Yeah, sure. Oh my god.
Okay. This calculation should just pan out. Okay, let's have a look.
Okay. So ignore the diagram on the left. Just like look at this diagram on the right.
Okay.
So, we assume that this angle is like the odd one out.
Yep.
And basically we look at the height of the yellow lines as, you know, they kind of go up and around. And basically, so we count, so let's say we have like 2n is the number of sides. Then we have n sides on this, we count n sides going in this direction, kind of like clockwise, and n sides going in the other direction. And the two endpoints, we compare their height along this line of symmetry, the green line of symmetry I drew.
Okay.
right? So basically, all the angles have to be the same, right? And exactly one of the lengths has to be different. So it's either on the right side or the left side of the green line, right?
Yeah.
So that means the height of the final endpoint has to be different.
Yes.
Yeah, so that's just done because then they can't be the same point.
Yeah. Nice. Okay. I'm just gonna finish off this calculation because I'm very sure this is done.
Okay, sure. Yeah, go ahead. I'll set up problem 3.
Yeah. Let me see. What is this simplified to? Hmm.
Tell me when you're done, by the way.
I'm very sure this is about to be done.
Oh my god. Do you want more space? We can insert a frame.
No, I'm just looking at this now at this point because I'm fairly sure this should just
Okay.
can't. I'm assuming I haven't made any mistakes, so I can just cancel out. So what is it? 2